now drawing up the circuit diagram for the modular crystal radio. First, I will show you circuit diagram of the output module. This is the output module, and we'll look at each component, how they're hooked up together. I'm using this tool to create my circuit diagrams for my crystal radio. It's called Schemit. You can access it by typing in digitkey.com. And this is the whole diagram of my audio module. The input is coming from the output of the tuner module. The meter we are using 25 microampere. It can flip both ways, negative and positive, with the needle at rest in the middle. The 10 microfarad allow the audio signal to pass through, while the direct current component of that will be driving the meter. In this way, you will not lower the volume of your headphone. On the bottom, we have a few resistors, VR2 and VR3, variable resistors. VR2 is a high precision VR, around 1K for this purpose. For VR3, you need 100 ohm. S1 switch in between the different ranges. In position 2, it will go to 250 microampere because some of the current has been bypassed by the VR2. Range 3 will be 2.5 microampere or 2500 microampere. It will be bypassed by the 100 ohm VR. Position 4 is the bypass. It will skip the meter circuit completely, so you can get the lowest loss as possible. Then we go to the other area called the bendy area, composed of VR1 500K in parallel with the 0.1 microfarad fixed capacitor. The function of the bendy is to condition the audio signal so that you can hear it properly without impacting the tuner circuit. And on the right, we have a very busy area. It is a auto transformer at the middle with the coil there ranging from 200K to 0 ohm. This is the impedance matching transformer. You can use the Chinese manufactured KPB02 if you can still find it because it has stopped production. Alternatively, you can buy the T725, which is a Chinese clone of the Belgian T725 transformer, or you can buy the genuine T725. It has less choice of impedance selection, but still it will work. We are using two rotary switches, S2 and S3. Each have 12 positions and a single input. You can choose from the impedance of 200K all the way down to 300 ohm for your input. So this part you will need to match with the output impedance of the audio module, which is mostly determined by your detector, whether it's a MOSFET, a diode of low impedance or a diode of high impedance. Sometimes it can go up to 100K. There's another switch called the S3 output impedance switch. You can select the output impedance to match with that of your earbud or headphone. It will go as high as 20K for your ceramic or crystal earbud, all the way down to 64 ohm. Because we only have 12 positions on this rotary switch, so we use the position 12 to connect to another smaller switch which has 4 positions called S4. So the first position of S4 will go to 32 ohm and all the way down to 4 ohm. You can see there's a terminal called 0. This 0 ohm is where you connect the common reference between your input and output. So usually we connect to the circuit ground, like what you see in the diagram. For the output jack, we got the J3, the earphone jack or headphone jack. Then there is another output jack called J2. This one is for you to record to your mobile phone. This one is hard connected to 10K ohm. This one cannot be used alone. You need to have a converter cable to hook up this capacitor around 0.05 microfarad and this 10K resistor. The 10K resistors is important. Without it, your mobile phone cannot detect any microphone devices inserted. For your iPhone, you will need some converter cable. For example, this is the one iPhone use. It has a Lightning connector and an audio jack at the end. Make sure you buy the one that can record. The cheap ones are only for playback. You can hear music, but you can't use the microphone connection. For your Android phone, there is something similar with the USB plug at this side. So you can buy it on any online shop. You can record and hear your music through the ear jack at the same time. The volume of your headphone will be lowered because some of the audio energy has been gone to the microphone. So that's all I have for today. I will continue to show you more circuit diagram of other modules.